Good morning, students. My name is Urmi Shah. I am Assistant Professor at LG Institute of Technology. I will be briefing you today regarding subject microcontroller and interfacing. Next module deals with rest all the modules, chapter number 7, 8, 9, 10, 11, all chapters are related to peripheral interfacing. Different peripherals we are going to interface that are listed here. So all the chapters, rest all the chapters are having the interfacing of different peripherals with 8051. So all this timer interfacing, keyboard interfacing, LCD interfacing, motor interfacing, ADC, DAC interfacing. So half of the portion from these chapters we will be seeing the practical applications of 8051 microcontroller by interfacing it with different devices, and we will be seeing the output for those devices.
Hi students, welcome back. In the previous video I explained about the analog to digital conversion. Now let us see the digital to analog conversion. So this is an 16-bit 16-pin configuration. Actually the digital to analog conversion converts it is used to converts binary numbers. Digital bit is nothing, digital information is nothing but the binary numbers. It converts the binary numbers into their analog equivalent voltage. Their analog equivalent voltage. So let us see the applications where we will use this digital to analog conversion. So in which areas we can use this digital to analog conversion. So the first application is we will use this in digitally controlled gains. Digitally controlled gains, and we are using motor speed controls. We will use digital to analog conversion in motor speed controls, and we will use in program gain amplifiers. Programmable gain amplifiers, etc. So this is some of the applications where the digital to analog conversion will be needed. So this is an AD7523, which is an 8-bit multiplying DAC. 8-bit multiplying DAC. So total here it is having 8-bit B1 to B8. B1 is indicates the most significant bit, LSB indicates least significant bit. So it is consisting of 8-bit multiplying DAC, which is this AD752 is a 16-pin DIP. It is a 16, one side 8 pin and another side 8 pin. So total it is a 16-pin DIP multiplying digital to analog converters, which is containing R to R ladder. So means this is R to R ladder. Here we are giving RFB. It is a 10 kilowatt, 10K we are giving for digital to analog conversion. And the power supply here it is needed is the plus 5 volts to V plus will be given to plus 5 volts to plus 15 volts. So the power supply we are giving to digital to analog conversion is plus 5 to plus 15. And the V reference in we are giving minus 10 volts to plus 10 volts. The reference voltage that will be given to digital to analog conversion is minus 10 volts to plus 10 volts. The maximum analog output voltage will be plus 10 volts. So up to maximum it can give the analog output voltage will be plus 10 volts. and a zener is connected to between out 1 and out. Here the out 1 and out 2 will be there. These will be connected to zener. It's a zener diode. A zener is connected between out 1 and out 2 to save digital to analog from negative transition. So to overcome the negative transition, a zener will be connected. Zener will be connected in between out 1 and out 2, okay, to save the digital analog conversion from negative transients. An operational amplifier used as a current to voltage converter at the output of AD7523. And external feedback resistance acts to control the gain. So these are all the points that you have to remember for whenever you are going for digital to analog conversion. So the voltage that is given and the voltage reference that will be given, and the maximum analog output voltage will be up to plus 10 volts, and a zener will be connected in between out 1 and out 2. Why we are connecting a zener between out 1 and out 2? To save the digital to analog conversion from negative transients, we are connecting the zener diode. And this is a pin configuration. Now let us see. So this is an interface. Let's see the example for the interfacing of DAC AD7523 with 8086 running at 8 megahertz. So here we are giving 8 megahertz. Now we have to write an ALP, arithmetic logic program, to generate a sawtooth waveform. Means this is an analog form. We have to take a digital data and you have to generate a sawtooth waveform of period, and the delay they are giving is 1 milliseconds with the maximum voltage is 5 volts. Actually, I said the maximum voltage it will be generate plus 10 volts. Now we are giving only 5 volts. So for that we have to write the program. That is a ALP program. First assume code segment. Now start. Move AL comma ATH. So first you are initializing this 8255. Okay, you are just initializing that 80 out, that whatever the data that will be there, that will be placed in the control word register. So now move AL comma 00H and put that AL in port A. Increment AL and compare AL with 0F2H. So if there is jump back, if there is a borrow, you have to jump back. When you are comparing, if a negative result, negative transient will come, you have to jump back. And then if it is not there, jump again. You go to this point, jump again. Code ends and end starts. So this is an interfacing of ADC, and let's see this. So this is a diagram of interfacing of AD7523 to 8086 through 8255. So in the previous, we are using digital analog to digital conversion. So that is a 080 and or 0809 will be connected to 8255. So now the 8255 will be connected to AD752, which is used to convert the digital data to analog. So here port A0, the LSB and MSB will be connected to AD752 pin 4 to 11 and the ground pin, and the V reference will be connected to 15th pin, and plus 10 volts will be given to 4th pin, and RF16 will be connected to 16th pin. Now see here out 1 and out 2. So which are connected with a zener diode. So this is a zener diode. So a zener diode is connected between out 1 and out 2, which is used to save the digital to analog conversion from negative transients. Okay, and this is which generates the waveform as an output. So minus plus connected. So this is an interfacing circuit of AD7523, which is nothing but digital to analog conversion. Digital to analog conversion. Thank you.